Hi everyone. In this video, I'm going to be walking through Cisco Packet Tracer 8.4.1.2. This is a skills integration challenge. The scenario is that our focus is on OSPF v2 and OSPF v3. So we're going to configure IP addressing for all devices, and then OSPF v2 for all the IPv4 portions, and OSPF v3 for all the IPv6 portions. We'll have one router configured for both IPv4 and IPv6, so it'll have OSPF 2 and 3. And then to verify everything, we'll test connectivity between all of our end devices. Alright, so let's go ahead and open up our packet tracer activity. And you can see that I've actually worked on this one for a bit. And I'm doing this one a little bit backwards. I have already gone through it, and my configuration was all correct. I mean, no red checks or X's or whatever, no problems there. But I'm having some issues with the connectivity test, and I don't know if this is just some kind of problem with packet tracer, but in any case, I'm going to do a reset on this, and we'll take it from the top. Alright, so to begin, we're going to use our addressing table to configure IP addresses, and we'll complete this portion. When we get to that, I have it completed in a Word document, so I'll pull that over so we can see the completed addressing table. And once we've done that, we'll set up the OSPF and kind of go one at a time through each router for the OSPF settings. Alright, so to begin, I'm going to minimize that and bring my completed addressing table over. And all my stuff's in blue there. Alright, so here's what we're going to be walking through, just getting into the router, assigning IPv4 addresses. So let's go ahead and do that. Get into the global configuration mode, hop into interface G00, assign an IPv4 address with a subnet mask. And most of this, for the routers, it's given to you. We only need my completed addressing table once we get to the PCs. So we'll come back and take a look at those when we get to them. Remember to give your interfaces the no-shut command to make sure they're not disabled. And there's our serial 0 interface. Again, remember the no-shut command. And then we want to start setting up OSPF. So router A, we only set up the 2 connected interfaces. That's all we need for this. And everything on this network is going to be IPv4. So pretty straightforward for all of that. And we'll go ahead and start setting up our OSPF. Process ID of 1. Router ID is 1111. And then we want to set up the network for each interface, so the network address. And we'll take a look really quick. We have the 3100, which is this network, which is going to be our switch and end devices out here. And then the 31.4.0 is the router to router. So go ahead and get those configured in here with our wildcard masks for OSPF and area 0. Go ahead and do the same for the second network or the second connected interface. And then we want to set the LAN interface as our passive interface, so passive G00. Alright, then we're going to move on to router B. So we can close router A, open router B. Come into the global configuration mode, and we're going to be doing IPv4 and IPv6 addressing on this router. And our gigabit 00 will have a link local address of FE80::1. So to begin, we'll jump into G00, give an IPv4 address first, and then we'll give it an IPv6 address, 2001 Delta Bravo 8 1::1/64, and then our link local IPv6 address was FE80::1 link local. Remember to give your no shut command, and then we'll move on to serial 0. And I'm going to move this back over, because I want to pull this one back up just to make sure that I'm not missing anything in our addressing table. Router B, serial 0, has an IPv4 address, not an IPv6. So IP address 72.31.4.2. Give it the no shut command, and then we'll jump over to S001. Give it an IPv6 address. IPv6 address. There we are. Right here. 2001 DB8 2::1. And again, no shut. You're going to see a lot of these messages come up with interfaces going up or down. Don't worry overly much about those. Some of these are going to say down because we haven't set up the next router. So, for example, this serial interface is showing down because it's down on this end for RC. So again, don't get too stressed about those. Those will change once we finish configuring the other router. Alright, while we're still in RB, we want to go ahead and give an exit command to get back to our global configuration rather than an interface configuration. And we want to go ahead and set up OSPF v2 first. So router OSPF, process ID of 1. Give the router ID 2222. Determine our network addresses for our IPv4 connections. So we're going to have one here for the LAN, and the other is here, router to router. With a wildcard mask. So 172.31.2 is the LAN network here, with the /23 notation. And our other network is our router to router. 31.4. Alright, and so we're fully up there. And then we want to give a passive interface to G00. We don't want it broadcasting routes out to the LAN network here. Nothing out there needs to know what these routes are. Alright, so that completes the OSPF v2 for IPv4. Now we want to set up OSPF v3 for the IPv6. So we're going to go ahead and move out of the OSPF IPv4, and we want to give the IPv6 unicast routing command, which enables IPv6. And then we'll set up the router OSPF, again with the process ID of 1. It might automatically pick up the router ID, but I'm going to go ahead and give it the command just to make sure. And we want to set it up on the IPv6 interfaces, which is the gigabit Ethernet 00 out here to the LAN, and then the serial 001 router to router. Here's the advantage to OSPF 3 is we don't need to configure this for the networks. We need to just set it up on the interfaces. So the command is IPv6 OSPF1 area 0. Quite a bit quicker and easier than having to worry about the network and the wildcard masks. And do the same thing here. For the serial interface to the third router. And we should be good there. And now our last thing is to finish configuring RC. And our routers will be completed. Come into the global configuration. This one doesn't have any IPv4, so we're going to jump straight into the IPv6. I'm going to give it IPv6 unicast routing command. And then set up the IPv6 router OSPF1. So it couldn't pick up a router ID automatically, so we will configure it manually. And then we just need to set it up on the two connected interfaces. So the gigabit 00 and serial 00. See if I can get that tooltip to go away. Anyways. Interface G00, IPv6, OSPF1, area 0. No IPv6 enabled. We did not set up the IPv6 addressing yet, so let's do that. Jump into interface G00 and do IPv6. I guess I didn't need to exit. Anyways, IPv6 address 2001 db8 3:1/64. And we want to give it the link local address FE80:3 as link local. I'll get my mouse out of the way there. Again, give it the no shut command, and then we'll jump into S000 and just give it an IPv6 address. So I'm pulling these directly off of here. So there's nothing special about those. They're already given to us. So we'll just use them. That's also a /64. Give it the no shut command, and our state will come up. We saw on router B that it showed it as down. Now that we've configured router C, that line has come up. So we're good there. Alright, so we have our addressing done on router C now. We'll need to go ahead and configure our OSPF. We've already given it the IPv6 unicast routing. I'm going to go ahead and give it again, just to make sure it's enabled. And then we'll start doing the router OSPF1. Router ID 3333. Make sure everything gets built correctly. And then we'll start assigning the OSPF to interfaces. And now we're not getting those errors, so we're good to continue on. Go to S000, OSP, IPv6, OSPF1, area 0. There we go. And I gave those a no shut when I was giving them addresses, so we're good there. All our routers should be set up properly now. The next thing we want to do is to complete this table. We want to determine what our PC addresses are going to be. So if we come down and look in the instructions, we have PCA and PCB. Their IPv4 addresses will be the last assignable address in their subnets. So we'll start with PCA. I'll move this over so we can still see what network we're working with. Go to their desktop IP configuration, give it a static IPv4, and we want to use the last assignable address in this network with a subnet mask and a default gateway that should point back over to router A. I believe, let me come up and double check our routing, our addressing table here. Yes, so we want to point PCA's default gateway should be router A's gigabit interface. Don't worry about the DNS or the IPv6 link local. That'll save automatically when we close it, so we can move on to PCB. We'll come back into its IP configuration, and PCB's IPv4 again will be the last assignable address in its network. So it's going to be 172.31.3.254. Subnet will be 255.255.254.0. And the default gateway should come back to router B's gigabit interface, IPv4. So right there. 172.31.2.1. And then for PCB, the IPv6 address should use the second assignable address in the IPv6 network, with the link local address as the default gateway. So what that means for us is we're going to take a look at our IPv6 network. We already assigned 1.1 to our router, so we're going to be assigning 1.2 for our PC here. So it'll be 2001 db8 1.2 with a /64. The link local address was our FE80 : what do we use for RB? Right there, : 1. And it says use the same thing as the gate for the gateway address. So we're good there. And then PCC is going to be the same thing. The second assignable IPv6 address. We gave 3.1 to router C right here. So we're going to give 3.2 to our PC. And so this PC is IPv6 only. To give the link local address as the default gateway. We have FE80: 3 with our link local for RC. Alright, and then we'll go ahead and close that to save it. Finish our documentation, and that's where I'm going to pull this back over to show all these completed addresses and gateways. I'll leave that there for a moment. So if you need to copy that down, you can go ahead and pause the video here and copy it down. I'm going to go ahead and move on. I'm going to verify our configurations and test the connectivity. OSPF neighbors should be established, and routing tables should be complete, in theory. Pings between PCA and PCB should be successful. Pings between PCB and PCC should also be successful. And so this is about as far as I got last time I ran through this, where my configuration was good, but something about my connectivity was causing some problems. And it has to do with the IPv6, which is the OSPF v3. If it hasn't converged, then that may be the problem. Sometimes it has to be removed and reapplied. I'm not going to run through the whole troubleshooting process in this. I just wanted to show mostly how to get it configured and set up. Troubleshooting is a whole another area that I'm going to get into hopefully in another video. But for the sake of keeping this one short, I'm going to call this completed. And if If you have any questions or comments, please feel free to leave them below. I may try to come back and leave a message down there about how I troubleshot and got my connectivity corrected. But no promises on that. I do have a couple of other movies I want to get made. So, hopefully I'll see you guys all in my next video.